taking limits to a further step, we're going to look at taking limits to infinity. So we want to see what happens to a function when you take x to extreme values, so when you take it to a positive infinity or negative infinity. So some of the expected answers you might get is a positive or a negative real number, maybe a 0, or an undefined. So this is when the limit does not exist because it goes to infinity, because the function goes to infinity. We will take x to infinity, but the function doesn't necessarily go to infinity. It might. So you have all these possibilities. So one useful tip that you should remember, which we're going to use very frequently to actually find the limits, is that the limit as x approaches negative infinity of a reciprocal of 1 over x is equal to 0, and as it approaches positive infinity is equal to 0, and the graph is shown in the previous limits video. You can test this out by also taking your calculator and trying out different numbers. So taking a really small number, so negative 1,000 or 1,000,000, and then also taking a really big positive number, so 1 divided by, again, 1,000 or 1,000,000. And you're going to see that the fraction will be a very small value, almost close to 0. So here are some of the strategies, and I'm going to do 2 examples to explain, but I would encourage you to try more examples on your own. So if I have this limit, I'm going to take x to infinity now, and the highest power of x at the moment is 1. So we have x to the power of 1 is the highest thing we could find. So what we're going to do is we're going to divide every single term here by this x. So I'm dividing by x, divide by x, divide by x, and divide by x. And then I'm going to simplify it. Okay, so I'm simplifying everything. I'm getting negative 2 plus 3 over x, 1 plus 1 over x. And this is what I mean, you should have no x terms in the numerator. None of the numerators have an x term in them because we've cancelled them out. So using the highest exponent property. So once we've done that, then we take the limit, and using the fact from the previous slide, if you're dividing 3 by a very big number, so you'll end up getting 0 here as x approaches infinity, and similarly here, as x approaches infinity, you're going to get 1 over x getting to 0. So what you're going to get is negative 2 plus 0 and 1 plus 0. We've already taken the limit, so I don't need to write the limit again here. And if I simplify this, then it's a negative 2. So the limit as x approaches infinity is negative 2. So that's one way to do it. You can even check it using a calculator. You can check it by substituting really big numbers as well. That's a trial and error method if you want to. But this is a numerical method to go through it. Let's try another one. You can try this on your own. Maybe try the first 2 steps on your own, and then I'm going to explain the 3rd step. So the highest power is 5, so I'm going to divide every single term by x to the power of 5. And once I do that, I'm going to cancel things out. Notice this time I'm taking the limit to a negative infinity just to spice things up. This will cancel out to a 1. This will simplify to 2 over x to the power of 4. This will simplify to 1 over x squared, and so on. So no x in the numerator, that's all good. Now as I'm taking x to the negative infinity, what happens is that all of these will get to 0. So what you're going to get is 1 minus 0 and 0 minus 0 plus 0. So you're getting a lot of zeros here. You're going to end up dividing by 0, which is not allowed. So actually you're going to have an undefined function here. So what we say is that the limit does not exist. Okay, and you might feel a bit uneasy about that. You can check using a graph. So this is the graph of the function, and if you notice, as I'm taking x to the negative value, so we're looking at this side here, so x is going to negative infinity, my y value will keep on increasing. So it's actually going up to infinity. There's no limit to my function. Now we want to link limits to asymptotes, which hopefully you can somewhat spot in some of the functions that you've done limits for. You can pause the slide and read it in more details, but I'm gonna do a different way of explaining this through an example. So if I take this function, which is 1 over x squared, what I'm gonna want you to notice is what happens in extreme values. So as x approaches infinity, negative infinity, positive infinity, and as the value gets, as x gets close to 0, what happens to the function? It keeps on going to infinity. So this all links to the vertical asymptotes and the horizontal asymptotes. And remember, asymptotes are vertical and horizontal lines where the function gets very close to but does not touch. So very similar to limits in terms of definition, somehow. So if the limit of the function as x approaches a certain value is either infinity, positive or negative infinity, then that value becomes the vertical asymptote. So if I give you any random number, if I tell you just test the limit as the function gets very close to 5, and it's not going to be equal to infinity, so you can say, okay, so 5 is not the vertical asymptote. But for this example, I'm telling you, well, can you test x equals to 0? And you test it out. Remember, we want to make sure that we're getting an actual limit. So you test it out from the negative side. So as x approaches 0 from the negative side, my function is going to infinity. And then you test it out from the positive side, and you notice that the function also goes to positive infinity. And we have the same, so the limit exists here because the right and left limits match. And the limit exists, therefore this 0 is now your vertical asymptote. So if the limit at a certain value is infinity, then this value is the vertical asymptote, and vice versa. If you already know that this is your vertical asymptote, then automatically the limit at this value of x will be infinity. So positive or negative infinity. So that's a trick for vertical asymptotes. And you can tell vertical asymptotes from a function. Usually when we define 1 over x squared, we usually say x cannot be equal to 0. So you automatically know that this is the vertical, this becomes the vertical asymptote. Now, for the horizontal, if the limit of the function as x approaches infinity exists, so you actually get a real number, then the limit is the horizontal asymptote. So in this case, I'm taking x to negative infinity, and my function ends up being 0. So then 0 becomes my horizontal asymptote. Similarly, for a positive infinity, it also becomes a 0, so y equals to a 0. So the horizontal asymptote is 0. So you can actually use these facts to link to asymptotes. I would encourage you to pause this and go through this worked example. I will explain it very quickly, and you can pause and repeat the video for details. So I'm not going to go through the sketch. I'm actually going to go through the asymptote. So as I said, use the domain as a tip for what the asymptote is. So let's just confirm that it is the vertical asymptote. So we look at x equals to 0, and using the table of values, you can see that the limit as it comes from negative, from the negative side is infinity, and from the positive side is infinity. So we can confirm that x equals to 1 is the vertical asymptote. The horizontal asymptote, we take x to positive and negative infinity. So if we take it to positive infinity, using the methods I've mentioned, we are going to divide by x everywhere. We end up with 2 over 1 minus 1 over x. This will go to 0, and so we end up with 2. Let's take it to negative infinity. We do the same thing. What I want you to notice is that you're dividing by two negative numbers here. So because you're taking negative infinity, so the negatives cancel out, the negatives cancel out. And then you have 1 divided by a negative number here. A negative and a negative will give you a positive. Now, it won't matter here. It's not going to be effective, but sometimes you just need to be careful when taking to a negative infinity. So in this case, it also simplifies to a 2. So actually, we won't get two separate horizontal asymptotes. We only get y equals to 2 as the horizontal asymptote, so we only get 1. And this is the graph of the function. So we have the vertical asymptote and the horizontal asymptote. Hopefully this video is clear. You can also expand your concepts of taking limits to infinity by looking at limits of sequences This is briefly about the geometric sequences, but you can explore it in in other types of sequences as well.